Download this code from codegive.com, link in the description below. OK, let's dive deep into the concept of composition over inheritance. This is a crucial design principle that promotes flexibility, maintainability, and avoids many of the pitfalls associated with inheritance, especially in larger projects. Understanding the problem with inheritance, and why we need an alternative. Before we get into composition, let's quickly review what inheritance is and why it can sometimes be problematic. Inheritance. What it is: inheritance is a mechanism where a class, the child or derived class, inherits properties, attributes and methods, from another class, the parent or base class. This creates an is-a relationship. For example, a dog is an animal. The lure of inheritance. Inheritance seems appealing because it promotes code reuse. You write code once in the parent class, and child classes automatically get it. It can also lead to a seemingly intuitive organization of your class hierarchy. The problems with inheritance: fragile base class, tight coupling, the gorilla/banana problem, etc. Fragile base class problem. If you change the parent class, you risk breaking all its child classes. A seemingly innocent modification in the base class can have cascading and unexpected effects throughout your inheritance hierarchy. Tight coupling. Child classes are tightly coupled to their parent. They depend on the parent's implementation. This makes it harder to modify or replace the parent class without affecting the child. The gorilla/banana problem. You wanted a banana, but what you got was a gorilla holding the banana, and the entire jungle. This refers to the idea that inheritance forces you to inherit everything from the parent, even parts you don't need or want. You might inherit unnecessary methods or attributes, bloating your child class. Inflexibility. You're limited to the inheritance hierarchy you've created. It's often difficult to change the behavior of an object at runtime or combine behaviors from different parts of the hierarchy in flexible ways. The diamond problem. Multiple inheritance. If a class inherits from multiple classes with conflicting methods, you get ambiguity about which method to use. Many languages restrict or completely disallow multiple inheritance to avoid this problem. Composition, the alternative, and the solution. Composition offers a different approach to code reuse and building complex objects. Composition. What it is: composition is a design technique where you create complex objects by combining simpler objects. Instead of inheriting behavior, you delegate behavior to other objects. This creates a has-a relationship. For example, a car has a engine and has a wheels. Key principles of composition. Favor has a over is a model relationships between classes using composition rather than inheritance whenever possible. Delegation. The composed object delegates responsibility for specific tasks to its component objects. Loose coupling. The component objects are relatively independent and can be easily replaced or modified without affecting the composed object significantly. Benefits of composition. Flexibility. You can easily change the behavior of an object at runtime by swapping out its component objects. Reduced coupling. Classes are less tightly coupled, making them easier to maintain and modify. Code reuse. You can reuse components in different contexts, building complex objects from reusable parts. Testability. Composed objects are often easier to test because you can isolate and test their individual components. Avoids the fragile base class problem. Changes to a component object are less likely to break the composed object, as the composition is controlled directly in the composed object. Code example: Python. Let's illustrate the difference between inheritance and composition with a classic example, modeling birds. 1. Inheritance example, the wrong way, demonstrating the problems. Analysis of the inheritance example asterisk. Asterisk we have a hierarchy, animal-bird-eagle, penguin. Asterisk the penguin class inherits the fly method from bird, but then has to override it to indicate that penguins can't fly. This is already a sign that inheritance might not be the best approach. We are essentially lying about penguins being able to fly in principle. Asterisk adding more types of birds, example flightless birds with other unique characteristics, would lead to more and more overrides, making the hierarchy complex and harder to maintain. Asterisk what if we want to add a swimming behavior? We'd have to add it to animal or bird, which might not make sense for all animals or birds. Or we'd create a new swimmer class and struggle with multiple inheritance. 2. Composition example, the right way. Analysis of the composition example asterisk. Asterisk we've separated the fly behavior and swim behavior into separate classes. These represent capabilities or roles that a bird can have. Asterisk the bird class composes these behaviors, it has a fly behavior and has a swim behavior. It doesn't inherit them. Asterisk the bird class delegates the fly, and swim, calls to the appropriate behavior object. Asterisk eagle and penguin are now simple classes that configure the bird class with the correct behaviors. Asterisk flexibility asterisk we can easily create new types of birds with different combinations of flying and swimming abilities. For example, we could create a duck class with can fly, and can swim. We don't need to modify the bird class or create a complex inheritance hierarchy. Key takeaways from the composition example asterisk. Asterisk has a relationship asterisk the bird class has a fly behavior and has a swim behavior. This is more accurate and flexible than forcing a penguin to is a flying bird. Asterisk delegation asterisk the bird class delegates the actual flying and swimming to the behavior objects. Asterisk loose coupling asterisk the bird class is not tightly coupled to the specific implementation of the flying or swimming behavior. You can easily replace can fly with a different implementation without affecting the bird class itself. Asterisk reusability asterisk the can fly and can't fly classes can be reused in other contexts, example for modeling airplanes or other flying objects. Asterisk no more overriding asterisk we don't need to override the fly method in the penguin class. We simply compose it with the can't fly behavior. In summary, asterisk inheritance asterisk. Asterisk is a relationship, example a dog is an animal. Asterisk creates a hierarchy of classes. Asterisk promotes code reuse through inheritance of properties and methods. Asterisk can lead to tight coupling, fragile base class problems, and inflexibility. Asterisk composition asterisk. Asterisk has a relationship, example a car has an engine. Asterisk objects are composed of other objects. Asterisk promotes code reuse through reusable components. Asterisk leads to loose coupling, increased flexibility, and avoids the fragile base class problem. When to use composition versus inheritance. Asterisk favor composition asterisk in general, prefer composition over inheritance. It leads to more flexible, maintainable, and testable code. Asterisk use inheritance when asterisk. Asterisk there is a clear and unchanging is a relationship. For example, a rectangle is a shape. Asterisk you want to inherit a significant amount of behavior from the base class, and that behavior is unlikely to change. Asterisk you are working with a well-defined framework that expects inheritance, but even in these cases, consider carefully whether composition might be a better alternative. Avoid deep inheritance hierarchies. Deeply nested inheritance hierarchies are often a sign of poor design. They are difficult to understand, maintain, and refactor. Advanced composition techniques. Dependency injection. Use dependency injection to provide the component objects to the composed object. This further reduces coupling and makes it easier to test the composed object. Strategy pattern. The composition example we used is a basic implementation of the strategy pattern, where you define a family of algorithms, the fly behavior implementations, and encapsulate each one in a separate class. The composed object can then switch between these algorithms at runtime. Decorator pattern. The decorator pattern allows you to dynamically add responsibilities to an object. It is a flexible alternative to subclassing for extending functionality. Mixins. In some languages, mixins are classes that provide specific functionality that can be mixed into other classes. This is a way to achieve code reuse without creating a rigid inheritance hierarchy. While technically using inheritance, the intent is compositional and not hierarchical. Conclusion. Composition over inheritance is a powerful design principle that promotes flexibility, maintainability, and code reuse. By favoring has-a relationships and delegating behavior to component objects, you can avoid many of the pitfalls associated with inheritance and create more robust and adaptable software. Always consider whether composition is a better alternative to inheritance when designing your classes.